Okay, so we're on 6F, guys, intersecting lines, and today we're going to look at using vector techniques to solve the intersection of lines in 2 dimensions. Once we've finished this, we'll look at converting it back to Cartesian form and just G-solving as we could do it on our calculator. So we're going to make a relationship between new vector form, and that's leading up to 6G, which you'll do next week, which is about lines in 3 dimensions. We may have a quick discussion about that today before we head off. So we have a triangle ABC. It was formed by 3 lines. We have line AB, we have line BC, and we have line AC. And they're all given to us in a different form, right? So AC is in Cartesian form, BC is in vector form, and AB is in parametric form. Now the first thing we're asked to do is draw the triangle on a grid, on a Cartesian plane. So we're just going to draw a very rough sketch of it so we can get an idea of sort of what it looks like and where things are intersecting and so forth. We're not going to sketch it exactly, okay? Let's just sketch the lines to begin with. So here's some Cartesian plane, right? And let's look at our line 1, and we'll call line 1 AB. And line 1 is, we're told x equals 3 and y equals 2t plus 1. So that is the parametric form of the equation of the line, right? And we're pretty familiar now at converting from that to x is 3, y is 1, plus t times 0 to 1 to convert into vector form, and then going to Cartesian form can be a little bit trickier. But all I want to say, if we're going to sketch this line, let's just look at the x value. We have x is 3. Okay, so that means it doesn't matter what the y value is, the value of x is always 3. Okay, so that means we have a vertical line at x equals 3. That's going to be the equation of line 1. Okay, for line 2, we have BC, line BC, and that's 4, 1 plus some parameter s multiplied by minus 1. That's the direction in which it's going. Okay, so if we're going to sketch that, all right, let's just do a very rough job. We know this is x is 3. The starting coordinate is across 4 up 1. So that's where it begins. And it has a direction of minus 1, 1. So that means it's going to the left 1, up 1. To the left 1, up 1. To the left 1, up 1. So that's going to have an equation like this. Alright, so we've got a sketch of it. I should label my axes. It's starting to look a bit confusing. X and y. And then our last line is in Cartesian form. So it is y equals minus 2x to take away 4. Okay, so just if we were to go to vector form or something like that, we need a point that it passes through. We know when x is 0, y is minus 4, because the y-intercept is minus 4, and it has a slope of minus 2. So that means its direction is it's going across 1, down 2. Across 1, down 2. Okay, so that could be a way of expressing it in vector form. Nonetheless, let's just sketch it as it is from here. We have a y-intercept of minus 4, so I'm going to put that about there, and a slope of minus 2. So it's going across 1, down 2. Across 1, down 2. So it's going like this. Okay, that's going to be our line 3. Alright, so we have these 3 lines, and they make up a triangle on the Cartesian plane. Okay, we want to determine the coordinates of ABC. Now, I think as well we should label this triangle. So we're told this is line AB, this is line BC, and this is line AC. And so that helps us to identify which coordinate corresponds with A, which corresponds with B, and which corresponds with C. So let's have a look here. This is line AB, and it meets line BC. The coordinate they share in common is B, so this is the coordinates of B. All right. This is line AB, and it intersects with line AC, so the coordinates where they meet are A, and So this has to be C either by process of elimination or using the same technique. And we can also already very clearly identify the x coordinates of both of these points. They exist on the vertical line x equals 3. And we can find the y coordinate quite easily. So here, all right, it exists on line AC. Line AC is this one, it's line 3. And I can have when x is 3, okay, if I put x is 3 in here, I'm going to have minus 6 to take away 4. My y value will be minus 10. All right, let's find the coordinates of B. Okay, so if we're going to find the coordinates of B, there's a couple of ways we can do this. All right, so we can think about it in terms of Cartesian form. We can think about it as if we know the x coordinate already. If we didn't know the x coordinate, let's show you one way we can find it. Now the coordinates of B is when line BC equals line AB. So that's line 1 equals line 2. So what that means is the x value of line 1 is equal to the x value of line 2. So the x value of line 1 is 3, and the x value of line 2 is 4, take away s. Okay? And the y value of line 1 is equal to 2t plus 1, and the y value of line 2 is equal to 1 plus s. Okay, and so this is a set of simultaneous equations that's going to tell us the value of the parameters t and s for which the lines meet. So if we can solve this one for s, if I take away 4 from both sides, I would have minus s equals minus 1, so this gives me s is 1. All right, so that means the solution, they intersect when s is 1, and if I solve for parameter t, if s is 1, we would have 2t plus 1 equals 1 plus 1, 2t plus 1 equals 2, 2t equals 1, t is half. Okay, so the parameter s equals 1 and the parameter t equals half when they intersect. And so if I put, let's show you why that's true. If I put s is 1 into line 2, if I put s is 1 in here, the y value is going to be 1 plus 1 times 1. So 1 plus 1, the y value is going to be 2. If I put t is half into here, I have 2 times a half plus 1, 1 plus 1, 2. So this confirms that the y value is the same when the parameter s is 1, that's what's occurring on line 2, and the parameter t is half, that's what's occurring in line 1. So we've got the x value, we've got the y value, we've got the coordinates of B. Let's find the coordinates of C, and all we're really doing, right, is substituting the lines into one another. So the coordinates of C is when line 3 is equal to line 2. Line 3 equals line 2. When are they going to be equal? Well, it's when the y coordinates are equal and when the x coordinates are equal. And in fact, all we need to do here is substitute in, if I put the x coordinate, which is 4 take away s, I'm going to put that where the x is, and the y coordinate, 1 plus s, I'm going to put that where the y is, and let's solve that for s. So I'm going to have 1 plus s, right? That's the y coordinate of line 2, and I'm substituting that into line 3. Equals minus 2 times the x coordinate of line 2. All right, the x coordinate is 4, take away s. All right, and then we have take away 4. Okay, is everyone okay with how I've generated this equation? All right, I'm taking it from here. Okay, we have y equals minus 2x, take 4. Here's the x value of line 2. And here's the y value of line 2. And then we're just going to solve that for s. So if we go through, let's expand first. We have minus 8 plus 2s to take away 4. we want to collect the s's on one side and the numbers on the other. So I'm going to take away 1 from both sides. I'll move that over there and take away 2s. We'll have minus s equals minus 8, take 4, take 1. And so I'll have positive s is 13. So these lines meet when the value of s is 13. And if I put 13 into line 2 to determine the coordinates of it, we're going to have 4 take away 13. 4 take away 13 is minus 9. And 1 plus 13 will be 14. Alright, so that's the coordinates of A, B, and C. Alright, so then we've got written for funsies, determine the area of the triangle, the length of all sides, and the size of all internal angles. So all of this is sort of assumed knowledge at a year 12 spec level, leading into a vectors test. So there's a couple of ways we can do it. We could use vector techniques that we're familiar with, okay? Now, however, now that we know these coordinates, we can really easily work out these lengths, the magnitude between them, just by using the modulus. Okay, so I can say, what's the length of that, what's the length of that, what's the length of that, and I can abstract a triangle out such that we know all of its lengths. Okay, and if we know all of the lengths, we can use cosine rule to find all of the internal angles. I'll leave that for you guys to do if you want. I'll just talk about the area. Okay, because you might go, oh, I could find the area once I know all these lengths. The area is actually really easy because the area of a triangle is half its base times its height. And we can very easily, we know that this is x is minus 9 and this is x is 3, right? And so the height of the triangle, all right, that's very obvious to us. The perpendicular height of the triangle, if I'm going from minus 9 to positive 3, that is 12 units, okay? That it exists, it has a perpendicular height of 12 units. And so we go half the base times the height. And what's this base distance? Well, if we go back to our diagram, it goes from y is 2 all the way to y is minus 10, so that's also 12 units, okay? So already we've established one length, one side length, and we've got that's 12 units. This distance here is 12 units, okay? And so the area of the triangle is half 12 times 12. Half of 144, 72 units squared. Okay, now I did want to just mention how we can graph these, because we've gone about this using a vector argument, and it's probably a sort of it's a longer way of doing it, but we're developing the skills ready for when we have lines in 3 dimensions. So probably the smartest way to do this would be to use our calculator and to use the Cartesian form of a line. So I'll just talk very quickly how we could do that, okay? The first line we've already got in Cartesian form, x is 3. It doesn't matter what the y value is, it's in Cartesian form. The second line we've got in Cartesian form, the third line we've got in Cartesian form. So that means if I'm going to find this line in Cartesian form, okay, what have we got? We've got it from the direction vector, it goes across to the left one, up one, to the left one, up one. That means this has a slope of minus 1. Okay? The change in y divided by the change in x, change in y divided by the change in x is minus 1. So if you think of y is mx plus c as the equation of a line in Cartesian form, we have a slope of minus 1. And we know it passes through, the point we're told is x is 4, y is 1. So we'll put 1 where the y is, 4 where the x is, and we'll have c is positive 5. So that means this equation in Cartesian form is minus x plus 5. And we can go onto our graph and sketch line 1, line 2, line 3, and just g-solve those points of intersection. Okay, very easy to do. Does everyone know how to graph a vertical line, x equals 3?
Yep.
Yep, good. So just on, I might come around and just make sure everyone can do that. But so if you can have a go at bringing these up on your calculators, and that'll be enough to get started on exercise 6F. I want you to try and use the vector techniques though. Why? Because we're scaffolding those skills ready for 6G that you'll do next week in my absence. Any questions about what I've gone through up here? Any questions about how to find the length of the sides? So maybe have a go at that